Hey guys, so in this video we're going to be talking about momentum and force and how they're related to each other. So momentum is defined or is known as P, vector P, is equal to the mass times your velocity. So it's a vector because of velocity, alright? Now, that's just your formula. Momentum, which is P right here, is equals to mass times velocity. You just multiply straight up, plug it in. All right, now let's do a little modifications here. So let me switch colors here. So now if we do the change in momentum, that means we're going to have to do the change in velocity, right? Final minus initial. You guys remember this? Now let's divide by change in time. Now what can you guys spot there? So notice how, what was velocity over time? Change in velocity over change in time is what? Simply acceleration, right? So mass times acceleration. And we also know that F equals ma, right? So force is ma, which is equal to mass times the change in the velocity over the change in time, which is equal to the change in momentum over the change in time. All right, so that was pretty straightforward. Now let's do a problem. Let's suppose a car is coming in. There's just a car. They're driving, and then all of a sudden the brakes just fail. All right, and then there's a wall here, like a wall. And let's suppose this wall won't move or get destroyed when the vehicle crashes. So they lose control, the brakes don't work, they're going towards a wall, and then they're moving at 30 meters per second. All right, the mass of the car is 500 kilograms. We know that this is your velocity initial. We also know that the velocity final is going to be 0 meters per second if the car comes to a rest after it hits the wall. And let's say the car comes to a rest in half a second. All right, so now the problem asks you, what's the force exerted by the wall onto the car? By the wall onto the car. So let's go ahead and plug it in. So from our formulas over here, we know that force is going to be equals to ma, which can also be equals m change on v over change on t, right? Now that is going to be simply 500 kilograms, the mass of the car, right? The change in velocity is final minus initial, so 0 minus 30, all this meters per second, of course, over the time, which we said was going to be half a second. All right, so now if you compute this, make sure you can pause the video and put it in your calculator, you end up having negative 30,000 newtons. Now you may be wondering what the negative means. So notice here how we said going towards the wall was positive, at least at 30. So what we're saying is going to the right is the positive sign, right? So then the wall has to stop it with an equal force going on the negative side. So the force exerted on the wall, the force exerted by the wall, it's negative 30,000 newtons. So by wall is negative 31k newtons, right? Let's not confuse yourself there. It's just negative 30,000, sorry, not 31, 30,000 newtons. And the force exerted by the car is 30,000 newtons. By the wall means it has to stop the car, and in order to stop the car, it must cancel out the same force that it has, right? Newton's third law, every reaction has an equal and opposite reaction in order to cancel each other out. All right, so those will be your answers. Negative 30,000 newtons, unfortunately, most likely the dummy, let's say it was a car crash, just so we don't kill anybody in this example, the dummy would probably suffer pretty big loss of an arm or something, because that is a lot of force, and that's a very, very small amount of time. So I hope this helped you see how momentum and force are connected, and how knowing the velocity and the time may help you with the force. And I hope this video was helpful. Let us know in the comments what you want to see, what you need help with, and what you would like us to explain. So good luck with studying, guys, and check out our next video coming out soon.